Hello and welcome. Today we're going to see how to calculate the concentration of hydrogen peroxide from a commercial bottle. Okay, the first thing we're going to do is to take 10 milliliters of the substance and we are going to dilute it to 100 milliliters. Okay, after that we will take 25 milliliters and we will add an excess of acid. We don't need to know how much, we just need to know that we have more than enough, and we are going to put it in the conical flask below a burette filled with potassium permanganate solution with a concentration of 0.05 moles per liter. This is a known concentration of permanganate. We're going to be adding permanganate solution until the equivalence point is reached. The equivalence point is the point at which the solution gets slightly pink, not very much and not colorless. When we reach that point, we write the volume, that is 20.1 milliliters as an example. Okay? Once we have the equivalence volume, we will write it down. The equivalence point, or the equivalence volume, is that point at which the number of moles of our permanganate equals the amount needed to react with the hydrogen peroxide present in the solution. This is the experiment as we have been doing it, and to calculate the concentration, now we will need to go back the whole experiment by making the calculation step by step. So the first thing is to obtain the number of moles of permanganate used, and to do that we will make use of the molarity equation. In this way, the number of moles will be equal to the molarity, the concentration of permanganate, multiplied by the volume of permanganate expressed in liters. Okay? In our case, we know that the concentration was 0.05 moles per liter, and we have a volume of 20.1 milliliters, that in liters is 0.0201. That gives us a number of moles of permanganate equal to 0.001005. We know that those moles of permanganate have been reacting with the hydrogen peroxide present in the solution at a ratio of 2 molecules of permanganate for each 5 molecules of hydrogen peroxide. We will have to introduce that relation of the two substances to calculate how much hydrogen peroxide was present in the solution. So we know that the relation is this, and we make the calculation by multiplying the number of moles that we have calculated before of permanganate by 5, corresponding to the stoichiometric coefficient of hydrogen peroxide, divided by the stoichiometric coefficient of permanganate in the reaction. And that gives us a number of moles of the peroxide equal to 0.0025125. We know that those moles come from the 25 milliliters that we put from the volumetric flask. So we can now calculate the concentration in the flask by dividing the number of moles by the volume of solution that we took. In our case, 0.0025125 per 25 milliliters that we took, and that gives us a concentration of 0.1005 mole per liter. This is the concentration in the volumetric flask, but let's remember that to prepare that volumetric flask we took 10 milliliters from the hydrogen peroxide. So this is the final step that we need to take into account. We know that the number of moles of hydrogen peroxide in the volumetric flask come from the bottle, and we know that number will be constant, so because we have only added water to it. So we can say that the concentration of the hydrogen peroxide in the flask multiplied by its volume is going to give us the corresponding number of moles. but that will be also equal to the concentration of the bottle multiplied by the volume we have taken from the bottle. And that, in our case, is 0.1005 multiplied by 100 milliliters. That is the concentration and volume in our flask. That will be equal to the concentration of hydrogen peroxide in the bottle multiplied by the 10 milliliters that we took from the bottle, 0.01. So we can work out the concentration of hydrogen peroxide in the bottle, and that will be equal to 0.1005 multiplied by 0.1 and divided by 0.01, and that gives us the concentration of the bottle, in our case 1.005 mole per liter. The following step is that you use your own data to make all the calculations, taking into account that you perform the experiment in one way, and the way back is the calculation. Thank you.